Hello guys, welcome to another video in the teamNetShot channel, and as in the last video we have seen the TCP Connect scan, we have seen the three-way handshake, how does Nmap determine whether a port is open, it's closed or it's filtered. And in today's video we're going to continue in that, and we're going to talk about the TCP SYN Scan. Right, so the TCP SYN Scan is toggled with the dash lowercase s uppercase s switch in Nmap, and it's quite similar to the TCP Connect scan, although there are some differences that we're going to be talking about in this video. Right, so as always, the TCP SYN Scan is also called the stealth scan or the open half open scan, and we're going to see why it's called this way. Right, so the first thing the Nmap does, as always, it's going to start with sending a TCP SYN Scan to the target server. The target server will receive the TCP SYN Scan, and it's going to respond with the TCP SYN ACK TCP packet. The SYN indicating that the server is also willing to synchronize with our machine, and the ACK flag to indicate that the server has received the previous packet of the client. So in the normal three-way handshake, in the normal TCP three-way handshake, our client now is supposed to respond with the TCP with the ACK flag set to indicate to the server that we have actually received its previous packet. But if we haven't responded, then the server will assume that we haven't actually received its previous packet. And if you done some networking or you took some networking class, then you know that TCP is a connection-oriented protocol, which means that it's going to retransmit the previous packet. So the server hasn't received the ACK TCP packet from our machine, then it's going to assume that our machine hasn't actually received this packet, so it's going to retransmit it again. So it's going to retransmit again the SYN a packet with the SYN ACK flag set. We're not going to be sending the ACK flag again, so the server, it's going to retransmit it again. Of course, this is not going to be happening forever. Depending on the server and its configuration, probably it's going to retransmit the same packet 5 or 4 times, and it's going to time out and it's going to close this connection. So to prevent this from happening, to prevent the server from retransmitting the same packet again, what Nmap does, it's going to send it's going to send a TCP packet with the RST flag set, so to indicate to the server we are going to reset. And what does that mean? It's just gonna tell the server, ignore everything that I sent you, I'm just gonna restart a new connection. Okay, so when Nmap receives this SYN ACK, it's gonna mark the port that we're scanning as being open, and it's gonna send the RST TCP packet to the server. Okay, so this is the scenario when the port that we are scanning is open. What happens when the port that we are scanning is closed? Alright, so when the port is closed, the target server will respond with a TCP packet with the RST reset flag set. So we're gonna, as always, Nmap starts with a TCP packet with the SYN flag set, send it to the server. Then if the port is closed, then the server has to respond with an RST TCP packet. So when Nmap receives this packet, it marks the port as being closed. Okay, now the third scenario is when we have a firewall, when we have the server behind of a firewall. And this firewall is configured to drop the incoming connections from all targets, from all machines, IP addresses except the trusted ones. So if the server we are connecting to is protected by a firewall, then the firewall might be configured to drop all the incoming packets except the packets that are coming from the trusted resources. For example, we have an SSH server, and we always going to be connecting from the same IP address. Our personal laptop, it's gonna it has a static IP address, then we could configure the server to only accept incoming connection from this IP address, and just simply drop all the incoming connections from other IP addresses. Right, so our client will send the TCP with the SYN flag set to the server. It's gonna intercept by the firewall. The firewall will just simply drop the packet and send no response. Now our client will gonna wait for some time, and if it didn't receive, it's gonna retransmit the SYN flag again for, I don't know, 2 or 3 times, and when it receives no respond, it's gonna time out, and the Nmap marks the port as being filtered. So those are the 3 possible states for the ports when scanning using the TCP SYN Scan, which are also the exact same case when you're scanning using the TCP Connect Scan. One of the differences between TCP Connect Scan and SYN Scan is the way that they handle the open port. So in case you're scanning using the TCP Connect Scan, then you're gonna complete when receiving the SYN-ACK packet back from the server, then you have to respond with an ACK packet completing the 3-way handshake. If you are scanning using the TCP SYN Scan, then to prevent the server from reconnecting to us, we're gonna send a TCP packet with the RST flag set to the server. Okay, so let's talk about the advantages of the TCP SYN Scan. First, it can be used to bypass older intrusion detection systems as they are looking out for a full 3-way handshake. This is often no longer the case with modern intrusion detection system solutions. It's for this reason that SYN Scan are still frequently referred to as stealth scan. Okay, so what does that mean? It means, so in the older intrusion detection system, it's gonna only put in the logs. The logs is just a file, all the connection that the server has established with other clients. It only gonna put the TCP that it has received this packet when it receives a TCP full connect scan, meaning all the 3 packets that are necessary for the 3-way handshake. If it did, and since we never send the last packet, which is the ACK packet, to finish the 3-way handshake, then it's not gonna be in the logs. This is only possible for the older intrusion detection system, since the modern intrusion detection system might log you as first as it received the same packet from the client, and that's why it's called the stealth scan, because it's not being saved in the logs in the older intrusion detection system. And it's also called the half open scan because we never open a full connection between the client and our the server, since we stopped this by sending a TCP RST packet to the server. Okay, so the second advantage is that SYN scans are often not logged by application listening on open ports, as standard practice is to log a connection once it's being fully established. Again, this is placed into the idea of SYN scans being stealthy. Okay, so the same idea. The standard practice is to log connections once it's fully established. So some intrusion detection system only save in the logs the connection once it's fully established, meaning we send the SYN scan, we have received the SYN-ACK scan, we have sent the SYN packet, we received the SYN-ACK packet, and we sent the ACK packet, and once that happens, then this connection will be saved in the logs. Okay, so the third advantage, so without having to bother about completing and disconnecting from a 3-way handshake for every port, SYN scan are significantly faster than a standard TCP Connect scan. So since we never completed the 3-way handshake, then we're not disconnecting because there is the fan. Since we connected to the port, we now need to disconnect from the port. So we send in the the TCP packet with the fan-ACK to the server to close the connection between the server. And actually, in Nmap, when using the TCP Connect Scan, as soon as it completes the three-way handshake, it sends in an RST flag to the server. So just keep that in mind. Alright, so now these advantages of the TCP SYN Scan. TCP SYN Scan requires sudo permissions in order to work correctly in Linux. This is because SYN Scans requires the ability to create raw packets as opposite to the default TCP handshake, which is privileged only the root use has by default. Okay, so to use the TCP SYN Scan with Nmap, you must be the root, or you must have sudo privileges, meaning you are in the sudoers group. If you don't have privileges, then you can use the TCP SYN Scan with Nmap. Okay, so the second disadvantage is that unstable services are sometimes brought down by SYN Scans, which could prove problematic if a client has provided a production environment for the test. Sometimes when you're not completing the three-way handshake by sending an RST flag after receiving the TCP accent from the server, this might stop the service from running. Okay, so this was our overview of the TCP SYN Scan. Let's now take a look at some examples. Right, so I've opened my terminal here. I'm using Windows. The commands I'll be typing will be the same since if you're using Mac OS or Linux. Okay, so you can either scan your home router, or you can scan your own machine. But if you could scan, Nmap actually has provided us with a website that we can scan. So the website is scanme.nmap.org. Alright, so the command would be nmap, and then you pass in the scan type, which is the stealth scan, the TCP SYN Scan, and we provide the target. Let me just scanme.nmap.org. And in the last video, we took a look at the -p option, which is used to indicate the range of ports to scan. So for time sake, I'll be just scanning one port, 80, and we have also taken a look at the reason option, which shows us why does Nmap thinks a port has marked the port as being closed, open, or filter. Okay, so that would be the command. Let's just press enter and wait for the Nmap to finish the scan. Okay, so that was quick since we are only scanning one port. So the port is 80 TCP and the state is open, the service is HTTP, and the reason why it has marked the port as being open is because it has received the SYNAC packet back from the server. Right, so let's scan let's omit the -p option, so it scanned the 1000 port, and let's introduce one new switch that is -vv for verbose, so you can see what Nmap does in every step. So okay, so now it's initiating the ping scan, and I'll be talking about this in ping scan just in a bit. So now that our scan has finished, we have got results, and we have some open ports like the 22 TCP SSH, and the reason because we have received a SYNAC TCP packet back from the server, and we have also the 80 port open. We got also some filtered ports like the 134, 135, and 139, and the reason because we haven't got any response. By default, the Nmap doesn't show the closed ports, and you can see by the note here, not shown 988 closed ports. So there is actually closed port, it's just that Nmap doesn't show them. Okay, so that's actually what the SYN Scan TCP SYN Scan is. And okay, so I said that I'll be talking about this where is it? The initiating ping scan. Because Nmap actually, when it performs the scan, there is phases to the scan. First, there is the host discovery, and there is the DNS resolve, for example, because we have given it a name of a domain, not the IP address, then it's going to resolve. So as you can see, host scanme nmap.org resolved to two IP addresses using 4533 to 156. So if you give it a name, then it's going to resolve the host name to an IP address to scan it, and then it's going to initiate the ping scan, because Nmap first needs to know whether the host is up and running or is down, meaning the IP address you give it, there is no up server with that IP address, and it's doing this by sending a ping to the server, which is an ICMP packet, echo an ICMP echo packet to the server, and the server, when it responds with a ping reply, then it knows that the server is up and running, and it continues with the scan. If it hasn't received the ICMP reply packet, then it doesn't do any further things, and it just quit the scan. Okay, and there is actually a switch in which you can skip the ping scan if you know that the host is up and running, and you don't need Nmap to send a ping scan to make sure you know that the host is up and running. And you can do this actually by, so just to recall the last command. So the command, the switch is pn skip the discovery phase, and the host is up. So if we have, so as you can see, host discovery disabled, all addresses will be marked up, and scan times will be slower. Alright, and about the DNS resolve, you can actually also skip this. So let me just copy the IP address of the scammy.host.control-C, and as you can see, the exact same result. Alright, so now we can give it, instead of giving it the host name, I can give it the IP address, and I can kill it -n. Do not do a DNS resolve, because I already give you an IP address. You don't need to do that. So okay, so now as you can see, there is no resolving. It's not resolving the IP address, because actually we have given it an IP address. Okay, so as you can see, we haven't done any host discovery, or we haven't resolved the IP addresses in DNS, because we have already passed it an IP address, and we have used the -n to prevent the DNS resolution, and we have passed it the -pn to skip the host discovery phase. Alright, so that was it about this video. I hope you guys learned something from it, and if you did, don't forget to subscribe, hit the like button, and you got any question, drop them down below, and I'll be happy to answer them. Thank you for watching, and have a nice day.